Hi, everyone. Welcome back. Sorry for the brief delay, but we're back up and ready to go now. It's my pleasure to introduce Dr. Erik Hoel. Dr. Hoel is a research assistant, a research assistant professor in the Allen Discovery Center at Tufts University, where he uses information theory and causal analysis to explore the biological basis of consciousness. He received his PhD in neuroscience at the University of Wisconsin-Madison, where he worked with Giulio Tononi on developing aspects of integrated information theory, and then went on to pursue his postdoctoral studies at Columbia University, working with Rafael Yusta. His current research at Tufts explores how complexity in information theory can be used to track or measure the neural difference between consciousness and unconsciousness, how causal structure changes across scale, and how information theory metrics can capture and quantify the emergence of macro-scale causal structure. Notably, in addition to his work as a neuroscientist, he's also an avid fiction writer who actually just published his debut novel. But today, I think he's going to be talking to us about his scientific work. And so without further ado, let me hand you over to Erik. Erik, nice to have you here. Welcome to Maine.
Yes, thank you so much. Sorry to all the viewers for this somewhat janky setup here, but I think we'll be all set and we can go through the slides. I wanted to talk today actually about something that's going on within the subfield of consciousness research, which is a debate around exactly how we can test and falsify theories of consciousness. Theories of consciousness have recently gotten a lot of funding, for example, from the Templeton Foundation, in order to kind of adversarially test different theories. And the question is really, how do we do that well? How do we do it formally? And it seems as if there might be some really sort of deep-reaching problems. So with that, I want to kind of take you into this debate that I think it's a little bit technical, but I think it's also quite interesting if you want to know what's going on. So just to start, these sort of debates about consciousness go back a very, very long time. We can go back all the way to early days of psychology with Wilhelm Wundt and William James, who are talking about how can we construct theories that tell us something about phenomenology. Wilhelm Wundt was asking questions already back then of things like, what is the simplest sensation? What is the structure of phenomenology? And William James is kind of thinking along the same lines. But at a certain point, consciousness research gets kind of, and then also this is, by the way, something that's going on historically at the time, right? This is a drawing by M.C. Escher in, I think, the 1920s, right? So science and art generally kind of feed off one another. People are interested in the same things at around the same time. But you get this rise of behaviorism. And by this, we kind of mean just that we're all in agreement that we're not really going to talk about consciousness or mental states. And this is around the 30s, 40s, 50s. And it lasts for a while, in fact, quite a long time. In fact, it took basically 2 different Nobel Prize winners to kind of break us out of this cycle of really not talking about consciousness within neuroscience. And that was Francis Crick and Gerald Edelman. And both of whom had won Nobel Prizes, and both of which kind of brought their own perspective to this new field of consciousness research. And in general, I think that the subfield of consciousness research can broadly, very broadly, be broken up into sort of 2 houses. The first is the house of Crick, and that is very interested in the neural correlates of consciousness. The idea is essentially that if we just collect enough data about the brain, eventually a theory of consciousness will kind of fall out of that. There's something to be said for that approach because, of course, it really keeps the subfield going, right? It's really important that people who are interested in consciousness and want to research consciousness can still kind of get funding. So doing things like basic neuroimaging and so on kind of keeps the engine going. But there's also this issue of, if we have something that correlates to consciousness, we don't really have a theory, right? We have a correlation. So nothing there is lawful. And an example might be like an early proposed correlation that came out of the House of Crick was something like maybe there's something going on with the gamma band in EEG. This frequency seems to kind of show up classically when subjects are perceiving things. So maybe there's some sort of correlation to consciousness there. The second house is kind of the house of Edelman, and this is the search for like a theory. And theory in kind of the sense of big overarching biological theories of the past, right? Things like the theory of evolution by natural selection, or maybe even something more precise, maybe something that looks even more like something from physics. So there are a couple of big theories of consciousness out there. One would be described as something like global workspace theory. So this generally emphasizes more the front of the brain rather than the back. And we can kind of think about it as a broadcast system. So there's kind of a broadcasting of information throughout the brain, and maybe this has something, to do with consciousness. And then you have something like integrated information theory, which is kind of what I cut my teeth on in graduate school. And integrated information theory argues that it's actually in the density of information integration that you would find consciousness. And the nice thing about integrated information theory, by the way, is that it's quite well formalized, and this is something it really doesn't get enough credit for. It's inspired a lot of empirical results, and as we'll go into, theories of consciousness, in the end, as they evolve and reach their mature state, they all kind of end up looking quite similar to one another, in the sense that they have a similar setup or a similar way to test them. And again, we'll go back to this issue of how can we tell between something like global workspace or integrated information theory. And this is necessary because, quite simply, we have no idea right now where consciousness begins or ends. Where on the tree of life does consciousness begin or end? You need to know that in order to make plenty of sort of moral decisions. And then also, nowadays it's becoming particularly pressing because we have these, intelligences, these artificial neural networks, which perform at an incredibly high level, something like GPT-3, which basically can use language. And yet we have no idea if it's conscious or not. So these seem to be kind of a really fundamental problems that hopefully a theory of consciousness would help solve. So I want to focus, some of this tale is going to be focusing in on integrated information theory. And integrated information theory, first of all, it's historically important for a couple of reasons. The first being that it's really was the first well-formalized scientific theory of consciousness. And I'll go into what I mean by that in a second, but I just want to give you a brief history of it. Without going into the details of exactly how you calculate integrated information or anything like that, what you need to know is that it was a substrate neutral algorithm for deducing the level of consciousness. It kind of expanded to talking about contents of consciousness. And perhaps the most importantly, I believe that it's first in a paper in 2012, it gets grounded on what are called axioms within the theory. And the notion is that IIT is based off of examining our own phenomenology, projecting that down into mathematics, and then using that as sort of a measuring stick for the consciousness of other physical systems. If you want to know more about early days of IIT, I highly recommend The Universe of Consciousness by Edelman and Zanoni. Nowadays, integrated information theory is quite complex. So the axioms that it chooses all have sort of some relationship to some particular mathematical postulates, and you end up basically calculating a very complicated algorithm in order to calculate the integrated information of a particular system. But I think the very interesting thing is that it's based in phenomenology. So I want to stress that historically, there's this very nice opportunity for a purely axiomatic theory that starts from introspection, at least in terms of guiding principles. So actually, this is something I've always really been interested in. So I was very lucky to kind of work on IIT. This is actually from my senior thesis all the way back in college, in which I was talking about collections of properties that any theory of consciousness must account for, the synthesis of which is to slowly fix any theory of consciousness in place. So basically, if we can kind of get enough properties of phenomenology, you really become constrained about what your theory has to look like. At least this was the idea. And I won't go into exactly all the properties of phenomenology that I think are important. This is, again, from my senior thesis, which, again, I've just been very lucky to be able to work on consciousness for a long time. It's quite a rare opportunity. So, do conscious experiences always involve a self? William James thinks so. We sort of have a naive realism about external events. Of course, when you're looking around the room or you're looking at this talk, you're not really looking at the talk, right? The talk is actually occurring inside your mind, and you're kind of looking at something within your mind. So we have this naive realism about the things in our conscious experience. That's a property of phenomenology. Very classic one, and the very basis of integrated information theory is that consciousness is integrated, which Kant called the transcendental unity of apperception. And so we can kind of think about stages of scientific theories of consciousness as, stage 0, you have a ledger of correlates, which is good, but the problem is that it's kind of infinite in all dimensions, and it's ungrounded, it's not lawful. Then you have sort of scientific theories. I guess somehow that's stage 2. I don't know where stage 1 went. You have neuroscientific theories, and then you have, and that might be things like maybe there's something involving recurrence or fame in the brain or higher order theories. Then you have phenomenological theories, which are really fixated on explaining properties of the structure of conscious experience and derive from that. And then maybe you have this ideal sort of hard problem solving theories, which might come after that, which might somehow kind of explain subjectivity itself. So how do we test any of these theories? So first of all, the obvious thing, theories of consciousness they're tested based off of observables, right? You look inside the brain, you kind of see whether or not your neuroimaging device or so on makes sense given what the people report, right? So everyone kind of knows this, but we should really point out that the observables, as in the data that is generated by your experiment, kind of need to be in agreement with report. And this is, in the end, what the whole enterprise rests on, right? In order to talk about that, actually, let me just discuss this for a second. So when you're testing and you're comparing reports to observations, we should be aware that you could falsify a theory of consciousness. So as a very simple example, let's say that I put a red painting in front of someone, and my theory of consciousness predicted that they were seeing a blue painting. Then clearly I would kind of have a mismatch of what my theory predicted versus what the person was actually seeing. And this would lead to a falsification of the theory. And again, I'm going to be speaking as if experiments are kind of perfect. We all know that if someone actually did that experiment, the first thing people would do is scream for replication and want like a much bigger effect size and so on. But like, let's put all of that aside and just sort of assume that we're talking about perfect experiments. In order to sort of test these things, as I mentioned, the Templeton organization, along with some others, are trying to, directly compare these theories. The question is, what's the formal framework within which one should do this, right? And as an example of where this can crop up, so a very old criticism of IIT, perhaps maybe the original big criticism of the IIT, came from physicist Scott Aronson, who wrote a blog post, I think maybe back in 2014. And this is actually his slide, stolen from one of his talks. And he's giving an example of how the IIT algorithm can give counterintuitive outputs, right? So as an example, here is like an XOR grid. And then the question is, it has very, very high integrated information. So is it kind of more conscious than even a human being just by being a really simple XOR grid? And this seems kind of ridiculous on the face of it. So Scott says, well, this can't possibly be true. But the problem is that while this is obviously sort of and his claim was, well, this seems like an unfalsifiable claim that this grid has some sort of high consciousness, right? Like that you've come up with some way to kind of fool the algorithm into having a high consciousness. He says, well, this doesn't make any sense. And also that prediction is not really testable. So first of all, it's actually fine if theories of consciousness make untestable predictions, as long as they're testable in some other way, right? So just because you can make an unfalsifiable prediction, that doesn't mean they are unfalsifiable. This would be like if physics told us something about what's going on inside of a black hole. even if you can never test that, if the rest of your theory is, holds up very, very well, then you should probably just believe whatever it says about what's going on inside a black hole. But IIT, again, runs into some other problems. And I want to stress again that the reason why a lot of this debate occurs around IIT is simply because IIT is well formalized. So you can actually talk about these things. So Adrian and his colleagues came out with a really great paper called The Unfolding Argument, maybe 2 years ago now. And in it, they argued essentially this. So they said, okay, the problem with IIT is that if you take some sort of neural network, we know that you can transform a recurrent neural network into a feed-forward neural network and preserve the input-output functionality of that network. Now, IIT is all about the integration of information. So that means information has to be integrated. If information only flows forward, it can't be integrated. So feed-forward networks notoriously have zero integrated information, again, according to the theory. So their point was that, well, this leaves us in a very strange position because we could take a network that would have some consciousness according to IIT, we could unfold it, and then the problem would be that we would have the exact same input-output. Now, the way they phrased it in the paper, where they don't really provide like a formal framework for it, they say things like, well, if you had brain imaging, you could differentiate these devices, but let's restrict that and so on. But I think, overall, I think it was a very interesting paper. And I think that theories of consciousness should kind of address these sort of criticisms head on, right? So what exactly does that mean? And what should we take away from a seemingly paradoxical case like this, right? So to try to delve deeper into this, Johannes Kleiner and I did a paper called Falsification and Consciousness that came out this year, in which we provide a big formal outline for exactly how to falsify and test theories of consciousness. And the main, one of the main resting points, or something that pretty much everyone agrees on, is that theories of consciousness can be falsified, particularly if there's a mismatch between what you predict from the theory and the report that people give you. So again, if everyone's saying, I'm seeing a blue painting, and your theory keeps telling you that you're seeing a red painting, it's probably evidence that something is wrong with the theory. So you could take something like global workspace theory and you could test it, and you could see if you could find a mismatch. And if you could, then that you would be falsifying the theory. Right? So, but that means that we can define the testing setup for theories of consciousness quite simply. So we think theories of consciousness should basically be thought of as functions or maps, right? And they're mappings from physical states to experiences. And where you can basically input the physical state, like the physical state of the brain, and you would get out some set of experiences that is occurring. So in sort of the full experimental setup, what we have is a physical system. We got observations from that physical system, and then, which is basically just the data that we can get from that physical system. And then we do two things. So first of all, we make an inference about what the consciousness of that system actually was. And that inference in humans is generally based off of report. So when you see inference here, kind of substitute it for report, just because it's easier to keep track of mentally. But it could be like, if a dog cried in pain, that would also be an inference, despite not really technically being report. And then you have your theory make a prediction. And hopefully your prediction off of some sort of internal data like brain state. And hopefully these two things, match up. And if they don't match up, then you have a nice falsification, right? So if your theory is predicting, for example, that something is totally not, that a person is non-conscious and they're awake and talking, right? Then you have a big problem because your theory should be falsified at that point. And this is just sketching this out more, where it's really saying that, listen, there's really these two functions that map the data to the set of experiences, one of which is the prediction of the theory, which is pred, and the other one, which is this function inference, which is like a report. And so, for example, here, someone is reporting an experience and it's mismatched with the one that is predicted, the experience that's predicted, right? So, well, this leads us to like an interesting observation, right? Which is that, well, if these two functions just don't really have anything to do with one another, they're just so in other words, if your report and your pred are just sort of different functions, then they can be varied, and that means that you can generate mismatches. So as an example, we took the unfolding argument and we sort of broadened it to be like, okay, well, let's, instead of just taking neural networks and unfolding them, let's just substitute in whatever we want that can preserve the same input-output profile. So again, here you have the, a neural network that you start with, and let's say that instead I take that neural network and I substitute in some sort of Turing machine that basically preserves the same input-output, but functions very differently in order to produce that input and output. And there's a lot of examples in the literature of specific ways in which you can do this. You're kind of very unconstrained in this sense. But this seems to be a problem because the likelihood that any theory is going to give you, the exact same predictions of the content of conscious experience for a recurrent neural network as for some very differently programmed Turing machine seems incredibly low. Like it seems like you're really going to mess up your predictions, but you fixed your report. So a way to think about this is that you have your function, which is your report function, and you fix it in place. You say, well, I'm not going to change that, but I am going to vary the system in all sorts of different ways. And then that will change the prediction of the conscious experience. So, okay, so that means that if you can change the prediction of the conscious experience, but while keeping the report identical. So here at the bottom here, we have just a visual representation of this, where you have your inference, where you're inferring from your data, like report data, what the experience is. So this would be like the system that you're looking at is still reporting the same thing, like it's saying, I see a car, or I see red, or whatever. But you're varying something about the system such that you vary your prediction of what the consciousness is, right? And this might be like a substitution. It might be like unfolding will be an example of this, but there's kind of all sorts of ways you can do this. You're sort of unconstrained. As long as you can fix that report, you're kind of allowed to vary whatever you want. But that means that you'll be creating mismatches, right? So just to say, as we're going through, by the way, we're giving kind of formal proofs of this stuff using this framework. So, just to lay it out, the intuition behind this proof is very simple. Essentially, in the virtue of the fact that inference and prediction are independent, you can always find a variation that changes the prediction content, and while keeping the inference content constant. It's kind of like if I just got two functions and they have no relationship, of course I can vary one without the other. That's like definitional. So if this is true, if there's independence between what report and predictions of conscious experiences, then the theory you'll always be able to find physical systems that give you mismatches. Now, when we say fixing the report, you can have debates about to what degree do you need to fix the report to kind of still have it be the same. Do you need to have it be exactly the same? This would be a case of something called like a universal substitution, wherein like a Turing machine that gives you the exact same input output as the neural network. But you could also imagine cases where you have like partial substitutions, wherein you have something that gives you something very similar, but different enough. So, just to point out, though, that even if we take the strong case of universal substitutions, we already know that they exist for something like integrated information theory. In fact, there's been a number of papers which haven't described it this way, but are talking about universal substitutions. For example, a paper back in 2019, where basically you have the exact same input-output profile for the system, but you have a very different qualia. You have a very different conscious experience, according to the theory, right? But you have a bunch of you can do it in all sorts of ways, right? So you can do it with artificial neural networks, but you don't even have to do like unfolding. You can just have a very different artificial neural network that has the same input output. You could do it with universal computers, right? So you could do it with Turing machines, which have extremely different architectures, right? If you apply a Turing machine, if you apply a IIT to a Turing machine, you'll get a very different answer than if you apply it to a neural network. Even if, for example, the Turing machine is running the neural network, right? You also have things like universal intelligences. There's the AI-XI model, which is sort of a gold standard for universal intelligence. It operates via essentially a very simple mathematical trick based on induction. There's almost no way. You could probably get it to have a similar input-output as some other sort of system. But again, it's operating very different. Like there's no way our brain, for example, just only operates by like Solomon induction the way that this thing does. And you almost certainly don't really need universal substitution. You probably just need partial substitution. Okay, and then I want to stress, this isn't a problem for IIT. It's a problem for all theories of consciousness. They just aren't well formulated enough to even apply this criticism. In other words, IIT just looks the way that a developed theory of consciousness looks like, where you can basically feed it an arbitrary physical system and it will give you some output. That is a very underrated thing. So, for example, you could feed IIT like a gas cloud, and it would say, "Yep, there's no consciousness here, right? This gas cloud isn't integrated. There's nothing going on here, right?" And so, because it's well formulated, we can kind of talk about these sort of issues. But with other sort of theories, they're not really well formulated, so you can't even really talk about these issues. But once you can, these sort of problems will crop up. So because you'll just end up, again, with some sort of prediction mapping. And that's going to then, if it's independent from your inferences, then that's going to be a really big problem. Okay, but you might say, well, this whole thing relies on this independence between your inferences and predictions. Sure, maybe that's true for IIT, but like, is that true for all theories of consciousness? Surely we can come up with theories where that's not true. Where they're dependent on each other. So you can't just vary one without the other and create mismatches that falsify your theory. Yeah, you can do that. But as we talk about in the paper, the problem is that then you begin to flirt with unfalsifiability. So rather than just kind of being a priori falsified by the fact that we know that there has to be somewhere out there a mismatch waiting for us, now we have this other problem, which is that it suddenly seems almost impossible to generate mismatches. In other words, there's no possible world in which there could ever be a mismatch, which means that your theory is unfalsifiable or tautological. And to give you an intuition of this, let's imagine that we take behaviorism very seriously as a theory of consciousness. And I'm not even saying that historically behaviorists advocated for this. But let's imagine that your theory of consciousness is just whatever people report it as, right? So you basically say, listen, I'm a total behaviorist. Your consciousness is just fixed by your behavior. Whatever you report is what you're conscious of, and that's it. So that theory is unfalsifiable because your inference function, how you're inferring your conscious experience, which is your report, is now the same as your pred, as your prediction function. So there's an identity there. And that means that you can't vary one without the other. So you can never have a mismatch. But that's because your theory is uninformative and tautological, right? And so again, this behavior theory of you are conscious of what you report, how could you ever be a mismatch between what you report and the predicted consciousness, right? So it's unfalsifiable. More broadly, access theories of consciousness are very vulnerable to this. So if you say something like, I think that consciousness is the information that's reportable in the brain, it seems as if you're saying something very deep there, but actually you're saying something very trivial because all you've done is push that back to talk about the brain, right? How could that not be? How could you ever get a mismatch? Whatever you report is what you're conscious of. Therefore, your reports and your consciousness will always match up. Therefore, your theory is kind of just, it's just not really a theory. It's tautological. It's empirically uninformative. And so we have some proofs about how that exactly is the case. And I think that there's a number of theories of consciousness that probably move more towards this direction than not. Okay, well, maybe there's a way out. Maybe there's a way out of this. Maybe you could have some sort of lenient dependency wherein you're not completely, the functions aren't identical, but they're also not independent, right? So that means that you could see a mismatch in some possible world, but you end up not seeing it right in this world, right? So the problem is that we can sort of describe what this lenient dependency looks like mathematically, like when you describe it within this formal framework. I don't think there's any theory of consciousness which has a lenient dependency between report and consciousness as currently exists. So right now, I think all scientific theories fall into either they're a priori falsified by universal substitutions, or they are fully dependent, and in that case, they're unfalsifiable. So it seems like you're sort of stuck between being a priori falsified and being unfalsifiable, right? So it's like Scalia and Charbitis, right? And like maybe there's this sort of like path through with lenient dependency, but broadly where I would expect theories of consciousness to fall, like things like integrated information theory, higher order theories, representational theories, even maybe neuronal global workspace, definitely stuff like gamma band. These are going to be all kind of a priori falsified. Stuff that's unfalsifiable and therefore is probably not very informative. Maybe things like illusionism, since again, you're like, how are you going to test that? Behaviorist theories, again, very broadly. Consciousness as accessible, reportable information. Again, how could you ever have a mismatch? Broad input-output functionalism also seems to be unfalsifiable. Maybe fame in the brain, but again, this now depends on the details, right? So stuff like fame in the brain, exactly how are you implementing it, and so on. Maybe all functionalism ends up being essentially unfalsifiable due to substitutions. So, okay, but my final message, and again, this is just to show you sort of the deep dive into the complexities of current thinking. Listen, if everything is a priori falsified, pick a phenomenological theory like IIT because it has a firmer basis. So there's kind of a funny way in which this argument is actually like a pro-IIT argument, because maybe the best that you can ever do are these phenomenological theories wherein you get something that is based off of your own conscious experience and relates to it, but you can't really rule out the fact that it's falsified, right? So. Alternatively, you could have evidence of experience that's not based off of inferences. This seems like it probably just requires solving the hard problem, but it would certainly obviate all of this. So, just go out. It's very easy, right? Just go solve the hard problem, and then we don't have to deal with this anymore. Huge thanks to Johannes Kleiner on this work. He's an ex-physicist, just a brilliant guy. And then this has been a very destructive talk. I don't just, and it's not even really meant to, but I don't mean to just like tear things down. Please feel free to check out my actual like constructive research, which is involving emergence. And then I recently have some work on the nature of dreams and something called the overfitted brain hypothesis that people here might find of interest. But thanks so much, everyone, for listening. And again, so sorry for the janky format.
Great. Thank you very much, Erik, for a very interesting talk. We have a few questions, and I think it would be good to take a few, though we are running a bit behind. So the most upvoted question so far is from Joshua. He asks, you said that access theories are not falsifiable, but they become interesting from a scientific perspective when they propose mechanisms, and at that point they are falsifiable, no?
Well, so in this case, right, the question would be, can your mechanism, can the total input-output profile the system? So really think about this as like you have a system, it's getting some input, it's then getting some output. We are inferring the consciousness based off of the output, which in a human would be like verbal report, but in a different system might be something else. And then we have a prediction. And then the question is from the theory about what the experience is. And then we're trying to match that up to the output. So the question is, if I fix the input and the output, but then can I vary anything within the system that changes the prediction, given that I've fixed the input output, right? So I'm constrained in how I can vary. And the answer seems to be that unless those two functions have an explicit relationship, there's going to be a way that you can vary the system. So even in a case where you have like an access theory with mechanisms or so on, you could vary the mechanisms, right? You could vary how it's done. You could vary all sorts of things about it. You could add in, parts that, you could add in time delays or loops or so on, right? You could kind of imagine like very evil neuroscientists who are almost like demons who want to force you into falsifying your theory, right? And these evil demons come in and they say, hey, wait a minute, if I just, kind of take one area of the cortex and unfold it and then hook it up to this other area of the cortex, I'll still get the same input-output profile for this whole brain, but all the information's flowing in a completely different way, right? And then these evil demons, right, are, they float in and they end up like falsifying your theory. And I guess the point of this research is that, listen, we don't really need to go through all that. We don't need to do all the experiments. If you know to begin with that your inferences are independent from your predictions, then there's going to be a way to do it, because I just have two unrelated functions.
So can I just ask though, Joshua, I was about to say what Joshua said as a follow-up. What you're describing seems to me to be a situation that holds for all scientific theories. I'm not sure I see why this is unique to access consciousness as a topic.
Well, so no, not necessarily. So one thing would be if for example, I have a theory which says that I am conscious of what I can report. Like, so what I can report, I'm conscious of. There's no possible world in which I can get a mismatch of that, right? That's very different from other scientific theories, where they're not just true across all possible worlds. If something's true across all possible worlds, it's generally a tautology. So,
but there can be differences between a person's behavior and their verbal output, right? So you can detect a mismatch between how someone's behaving and what that indicates their brain is doing and what they verbally report as their experience of something. And that mismatch can be precisely the kind of thing that can be used to falsify such a theory.
Yeah, no, it depends. So if it's actually the case that what you can report, right, is what you are conscious of, like that's your theory, right? Then those two pools of data are the same, so they can't be any different. If you're saying they're not the same, well then now you're in the other regime, right? Now you can have mismatches, and now the question is, okay, given that we have the possibility of mismatches, is there any way to vary the internal workings of the system such that we throw a mismatch? And then the answer is generally yes, unless there's some other sort of special thing. I think that the stronger objection to this is some sort of reductio, which is so the stronger response to the whole substitution argument is some sort of reductio that involves like saying that like wait a minute, perhaps we can sort of describe other sort of scientific hypotheses like this, and then can we fit them into this same formal framework? And then if they do fit, then there has to be something wrong, even though that doesn't tell you what's wrong with the argument. But you say there has to be something wrong because it just can't be the case that like all of science is either automatically falsified or unfalsifiable. But you really can't fit them in because in general the thing we're interested in consciousness is the output of this rather complex system, and we don't have any sort of direct evidence of it. Like this is the old classic problem of neuroscience is that when you open up the brain, you don't see any experiences, right? You see like Leibniz's mill where you have other stuff going on, so you can't directly observe experiences. And if you could directly observe experiences, then this whole thing would be moot. But and that would be like solving the hard problem. But we can't directly observe experiences, and so therefore we're in a very different situation than most of science.
Well, okay, let me move on to the next question. This is from Charles. He asks, in his work, Edelman does provide basic guidance as to where consciousness begins or ends evolutionarily. He assigns progressively higher degrees of consciousness, as he defines it, to a few different organisms. By the statement, we have no idea where consciousness begins or ends, are you opposing his views or claiming that they are unsatisfactory? And if so, why?
Well, So I would say that we should be honest about the fact that there is no well-accepted scientific theory of consciousness. There are somewhat one might call field leaders. I would include IIT, global workspace theory, maybe some stuff about recurrent, which is kind of similar to IIT, like kind of blends of those two ideas. But still, even within those leaders, we really just don't know. So I'm quite comfortable saying that we're not sure where consciousness begins or ends in the tree of life. Everyone can kind of have their own intuitions about that. But in terms of Edelman, again, if you go back and you read his work, what you'll find is not a theory with which you can make precise predictions. Quite simply, there is a fact of the matter about what each of us is experiencing right now. We have a stream of consciousness. And so there is some sort of, fact of the matter about how that's generated and the rules and laws by which brain activity generates that or is related to that. Pick your relationship verb. But that is generally not captured by most theories, which are much more like metaphors. Like, for example, maybe there's something like neural Darwinism, or maybe it's kind of like a remembered present, or so on. Maybe consciousness is kind of like this, maybe it's like that. But in the end, I think that when you get really serious about it, scientific theories of consciousness end up looking like functional mappings between physical states and experiences. And that's the sort of theory that we're interested in. And that's also the sort of theory where you can talk about these sort of issues. I mean, I think that the theories that look like they avoid this just don't, just because they're not well formalized.
Okay. Well, thank you very much. I think we should probably move on because we're 17 minutes late right now. But thanks again for a fascinating talk, Erik. And thanks for joining us here at the Montreal AI Neuroscience meeting.
All right. It's been a pleasure. So sorry for going over.
Not at all. It was our fault for starting late. Thanks.